All right. Welcome in, everybody. I hope you're having a wonderful day so far. Today is a wonderful Saturday, May 17th, 2025. Feeling good, feeling refreshed. Oh boy, I slept in today. Felt real nice, let me tell you. Felt real nice just being able to roll back over and. Let me tell you. All right, let's get the old lights plugged in. Let there be light. I got to get a new light bulb for my lava lamp. It burnt out, so we're short on a light bulb right now, unfortunately. Um, but hello, welcome back in, everybody. So today, we're going to be watching this Corey Schaefer video on web scraping with BeatifulSoup and requests to get some more familiarity with web scraping, right? So we can um, scrape the PubChem webs page here and get the information if applicable, right? So that's what I wanted to focus on today. Um, Hold on a sec. Hello, Tim. Mr. Timmy Tim Tim. On your chinny chin chin. How's it going, Mr. Tim? Appreciate you joining me here. Welcome back to the stream. Let's go ahead and get a couple of tunes going here. What do we want to listen to here? Come on. What's for today? Hmm. One sec. Come on, give me some. I want to listen to. Hey, yo, Mitchie. How's it going, my friend? Hey. This one's for you, Tim. Mr. Tim, move that head. Hey. Woo, woo, woo. All right. Let's vibe out for a second. I'm gonna grab a little bit of a drink, not a drink, but just a lemonade. I went to Costco, did a little Costco run. Um, Dude, they missed some stuff on the scanner, and they stopped me like, you're missing some items on the receipt. I'm like, what? So I had to go back and I had like one thing that wasn't scanned, so I was like, all right, whatever. So I just followed them and did whatever they want. I don't care. And let me go get some lemonade, and we'll get this going. So we're learning web scraping, so we can get into web scraping on some where's that page? Oh, did I get rid of it? No. Right. So we want to scrape these pages and get the information off of them, right? So let's go ahead and get into this. I'll be right back. I'm gonna be right back. All right. Welcome back. Welcome back. Let me grab my blanket. Hey, Tim. This one's for you, Mr. Tim. This is my go-to study blanket. Rip City, baby. Portland Trailblazers for sale. Did you hear about that, Tim? Did we talk about that, Tim? I think we did. I literally called it. A couple weeks ago, I said, Jody Allen, please sell the team. They're selling. Let's go. Let's see what happens. Hey, Stoic. How's it going? React Native stuff. Yeah, we're going to get into that here. Probably tomorrow on tomorrow's stream when we start going for kind of laying out the front end of our spectrosim.com, right? So yesterday's stream was really cool. We put together the algorithm for developing absorption spectroscopy simulations, right, via Python, so we can plot now compounds with off of some JSON reading, and so now we need to actually figure out a way to access online information, and I figure this would be a good project to maybe do some web scraping to see if we can scrape some data off the web and maybe have our own database that way rather than accessing someone else's and having some lag take place. So let's go ahead and, get some information ourselves and let's scrape it up, shall we? I'm moving to Mexico City. No way. Get out of here, bro. If anything, they would move to Seattle, but that's not gonna happen. I think they've got to stay in Portland. They've got another 5-year contract on their arena in Portland. And I'm not sure if they can get out of that. I think they have to stay until 2030 in the Moda Center, the Rose Garden. All right, let's go ahead and get into this video. So I'll show you guys my project we wrote yesterday. So if you guys haven't seen, the code is actually on my GitHub. So in the description go ahead and access the repo on my GitHub. Make sure to give it a star. It's going to continue to grow, and you can follow along as I develop this into its full stack framework. So it's going to be pretty cool. I'm super excited. It's going to be like the chroma plot. No, I grew up in Portland. That's where I was born and raised. Portland Trailblazer fan, big from back in the day. Brandon Roy, Travis Outlaw, Greg Oden. I liked Greg Oden, but it didn't work out, unfortunately. Could have had Mr. KD. Who else we got? You got Sebastian Telefair, Martell Webster. You got who else? You got obviously LaMarcus Aldridge. You got like Roy Prisbilla. You got, or is it Joel Prisbilla? Joel Prisbilla, sorry. You got, you had like at one point Andre Miller. I could not stand Andre Miller. Tim's probably getting all these names. We could have had Michael Jordan, but we took Sam Bowie. Yeah, tough. We could have had Chris Paul, but we took who did we take instead of Chris Paul? I can't remember. Yeah, dude. Portland's had some terrible luck with draft picks, but we got Dame, but didn't really amount to anything if we're actually title-wise. Definitely made a mark in improving the city of Portland and basketball's mindset because of Damian overall, but definitely not anything title-wise to brag home about. Yo, Stoic. The league is expanding to Seattle and Las Vegas before 2030, so I don't think the league would approve any move. Yeah, they're gonna expand, but it's interesting. Is the expansion like it's gonna be? I think that like isn't the league suffering like in terms of haven't they started declining in terms of like monetary value here? you know? Let me go ahead and pull up the chat on there. All right, let's get into this video. Oh, I'll show you guys my thing here. So yeah, the code is on GitHub. You guys can check it out. This is where we're going to scrape data, right? We're going to scrape it and load it into a JSON in this format, and then we're going to, and so you can get these plots basically of, you know, at various wavelengths, certain compounds absorb a lot more energy, and so you can use this to kind of, you know, for predictive purposes and medicine and things like that. You know, at what, you know, how can we, you know, block certain functions or you know, whatnot with certain I don't know. It's really kind of complicated how these serve purpose in the real world, but it's definitely something that goes on. I want to kind of mess around here, and I want to see what happens if I kind of make these. So we already recognize that the concentration just increases the amplitude, right? So what happens if we going to copy this down, right? And then I'm going to say, I'm going to access compound number, that's just fine. And I want to say, what happens if we make the, so obviously this will change the location at which, if we make this like 200 and run this simulation, this changes the location at which on the x-axis the peak happens in, kind of where the Gaussian curve will form around that peak, right? So that, but what happens if we change this value? What happens
Tim
if we make
says
it
the
like
Celtics sold for $6.1 billion, a record for a North American team, and the NBA just signed a $76 billion media rights deal. They are for sure cooking.
Okay, so maybe they were kind of just on like a little bit of a down slope, and then they're going boom. So maybe the NBA. I wish the NBA was like an IPO you could invest in instead of a private company. Okay, so what happens if we change this by like half? Let me get like 8,000 and run this. So that's that. So this is just 0 through 80. Now if I change it back and do it, so it just reduced the amplitude by half again, by half. So by changing the ellipse epsilon max.
Duardo says, Bitcoin is a good investment.
I don't touch that. Okay, so then if we change this to like, let's say we make it 200 and run.
As says, domains are the next property.
Oh, get some weird, interesting stuff with Sigma here.
As says, real estate.
Domains, you think? What kind of domain names are you stacking up on, AZ?
Tim says Mike hates Bitcoin, don't get him going.
I don't hate it. I just don't. I'm not a believer. I mean, yeah, it has value in terms of what people give it, but I don't. I'm kind of like I'm like that grouchy old man or like that one kid in high school or whatever that doesn't like do what everybody else likes to do.
Anything.
Like, that's just like the
As
like
says there aren't
just to
enough.
be annoying. But that's what, you know, unfortunately, that's kind of what sometimes makes you some dough, because if sometimes when you go against the curve at the right time,
I will remember this when Bitcoin hits $1 million.
it probably will, dude. I just, you know, I don't know.
Stoic says, how do you do the text to speech?
It's just through the social stream app I have here. Okay.
Duardo says, Bitcoin is computing with financial markets.
Yeah, we don't need to get into all that. All right, let's get into the video here.
How's it going, everybody? In this video, we'll be learning how to scrape websites using the BeatifulSoup library. Now, if you don't know what it means to scrape websites, basically this means parsing the content from a website and pulling out exactly the information that you want. So, for example, maybe you want to pull down some headlines from a news site, or grab some scores from a sports website, or monitor the prices of some items in an online store, or something like that. Now, to show an example of this, let's take a look at the finished product that we'll be building in this video, and then we will learn how to build it. So I'm here on my personal website, and on my homepage here, I have a lot of different posts of my most recent videos, and every post that I have has a title here that is a big heading tag, and then I have a text summary of the video here, and then I have a link to the video. So let's say that we wanted to write a scraper that would go out and scrape all of this information. So I wanted to grab all of the post titles and summaries and links to the videos from my homepage, and I wanted to ignore all this other information. So to do this, I have a finished version of what we'll be building in this video, and then we'll learn how to build it. So right now I can just run this with Python, and this is called cmsscrape.py. So if
Bro, no!
Let's just see what
Come on! Don't do me like that. Don't do me like that.
If I run this, then this went out and scraped all of the titles and summaries and links. So we can see here we have a title. So this is my CSV module video. And then we have the summary text here. And then we have the link text here. Now, not only did this go out and scrape this information from the website and print it out here in the terminal, but it also created a CSV of all this information as well. So if I open up this
Do you guys like to watch first and try to code a project
CSV,
of yours
this
after?
should open it up in numbers, but you can also open it up in Excel.
So I'm kind of like,
this isn't very
it's kind of like I do it
readable
on and
right
off.
now,
Like I'll
but
learn
if
a little bit
I
and then go do it, then learn a
make
bit
these
more, do a little bit more.
columns
Because I get
little bit
excited and I want to
smaller
get started.
here, and then wrap this text, then we should be able to read this. So you can see we have a column that has all of our headlines for all the articles on this. So
Okay.
first of all, let's make sure that we have everything installed that we need. So to install BeatifulSoup, you can just use the pip install command. So to do this, we can just say pip install, and this is BeatifulSoup, and this is BeatifulSoup 4. So you can see that I already had that installed, but if you don't have that installed, then yours should just go through the installation at that point. Now you definitely want to install BeatifulSoup 4 because there is an older version just called BeatifulSoup, but BeatifulSoup 4 will give you one that's most up to date. So once that's installed, then we need to make sure that we have a parser to parse our HTML. Now,
Okay, hold up. We're gonna kind of follow along here, so we can kind of apply it to our project. So I'm going to just make a in our SpectroSim folder here. Let's make sure where we're at in our. So let's go git status raw branch dev ahead of origin dev by 1 commit. Okay, so we got to push. Okay. So now we're on dev still. So let's go ahead and branch off our dev branch. So let's go git checkout -b, and let's do dev web scrape. Okay, now let's go ahead and we're on this branch now. I'm gonna go git I haven't made any changes, so I don't think I can add and commit on anything. So if I want to push upstream on this branch, so I probably should push upstream on my dev branches so you guys can see them too. Okay, well, let's just get into it here. So we want to, let's just make a new file here. Let's go touch We'll say make dir. We'll go cd database. Nah. We'll just go touch web scraper dot py. And that's code. That's code web scraper dot py. Okay. So now what we'll do is we'll go here, git add git commit here, and we'll say start web scraper dev web scraper git push. We're gonna have to say git set origin dash upstream. I'm not gonna risk it. So we'll say git push here, and we'll get denied. Git push set upstream origin dev web upstream. Okay, that was close. So we'll push this up so you guys can track it. My changes here. Is this not auto saving? Web scrape. Wait, what happened? Why is there web scrape and web scraper? Oh, I think something happened. Okay, whatever. A dude got sued out of his domain by Microsoft. I think they have a known brand with that name, then they can take it. Oh, interesting. So you can't there's some rules, AZ, against sniping domains. If they can prove that they have just a overarching established brand that is recognized as that name, it's theirs, by inference. That's kind of interesting. How do you guys feel about that? Okay, let's keep going.
Now, I won't go deep into the details of these parsers, but there.
Oh, so hold on. We got to do pip install beautiful. I always suck at spelling this word. Soup 4. Cannot find a version that satisfies the requirement. Oh, yeah, I spelled it wrong. Pip, come on. Install beautiful soup 4. Here we go. All right, and then we'll go. Let's get into this.
But there are some small differences between the parsers, and they could return different results depending on the HTML that you're trying to parse. Now, if
hey, Ron, how's it going?
Perfectly formed HTML,
appreciate you for stopping by.
Those differences aren't going to matter. But if there are mistakes in the HTML,
hey, Wolfie Master on Twitch,
will
I see you.
Fill in missing information differently. So BeatifulSoup has a section in their documentation about the differences between those parsers, and basically they suggest installing and using the LXML parser. So that's what we're going to use in this video. Now, they also say that the HTML5 lib parser uses techniques that are part of the HTML5 standard, so you could use that one too. But most of the time, the choice between the parsers isn't really going to matter all that much as long as you're working with good HTML. But I'll go ahead and leave a link to the differences between those parsers in the description section below if you want to read more about those. So to make sure that we have the LXML parser installed, we can install it.
So I have a hot take. AI is not just a buzzword if you use Monday CRM.
I'm so glad you said that. So for me,
with pip also. So we could just say pip install, and that is LXML. So if we run that, then I already have that installed, but yours will install there if you don't already have that. Now, if you want the HTML5 lib parser, then you can just do a pip install HTML5 lib. So like I said, we'll be using LXML in this video, but the HTML5 lib is popular as well.
What's the difference? Did he mention it? I wasn't paying attention. I'm an idiot.
No. But I'll go ahead and leave a link to the differences between those parsers.
BeatifulSoup presents the same interface to a number of different parsers, but each parser is different. Different parsers locate different parsing trees versus the same document. The difference the biggest differences between the HTML parsers and the XML parsers. Here's a short documentation. Parse as HTML using the parser that comes with Python. BeatifulSoup, this HTML parse. Since a standalone bold tag or just is not valid, HTML parser turns it into a double bold tag pair. Here's the same document parsed as XML. There's also a difference between HTML parsers. If you give a BeatifulSoup a perfectly formed HTML document, these differences won't matter. One parser will be faster than the other, but they will give the data structure that looks exactly like the original HTML document. But if this document is not perfectly formed, different parsers will give you different results. Here's a short invalid document parsed using XML's HTML parser. Note that the anchor tag gets wrapped in the body and HTML tags, and the dangling paragraph tag is simply ignored. What is the diff between HTML and XML parsers? The key differences between these parsers and Python comes down to speed, robustness, and standard compliance and dependencies. In built-in Python module, HTML parser.html parser, no installation required. XML, external library must be installed, built on top of the C libraries. XML is slightly faster because it's written in C. HTML parser is pure Python, so it's slower for large documents. Parsing robustness. LXML handles messy or malformed HTML better. It's known for being very tolerant. XML has full XPath and XSLT support. We're going to be going through some larger database things, and you might see this is pretty caked with information, so let's go with the XML. Okay, pip install
parsers and the parser installed, we can install it with XML. So if we run that, then I already have that installed, but yours will install there if you don't already have that.
Making
now,
moves.
If you want the HTML5
Making
lib
moves.
parser, then you can just do a
Skewy Chess, welcome back from your timeout. Hopefully,
so like
did we learn a lesson about spam in the chat?
This video, but the HTML5 lib is popular as well. So now we also need the request library, and just the same, we can do a pip install request and run that. You can see that mine's already installed, but if you don't have it, then yours should get pulled down right there. Okay, so now that we have those installed, let me clear that out. And now let's take a look at what we can use these for. Now, you don't have to be
so far so good
familiar with HTML in order to scrape websites, but it definitely helps to know. So basically, HTML is structured in a way where all of the information is contained within certain tags. And if you're at all familiar with XML, then it's very similar to that. Now, I have a very extremely basic HTML file open here in my browser. So we can see that this small example just has one big header here that says test website. And then we have two large links here for articles, and one is the article.
I appreciate you for coming back, though,
Skewy
Chess. That shows some
that. And then we have
integrity
a
and some
article
heart.
2 headline here with a text summary below that, and then we have a footer down here at the bottom. Now, this is how browsers display HTML. We are using the Chrome browser right now, but in the background, the source code looks a bit different. So I have the source code for this very basic website pulled up over here on the right side of my screen. So let me make this a little smaller here, and then I will stretch this over so that we can better see the source code. So we can see how this is structured. So we have these tags throughout our document, and there are opening tags that are surrounded by these angle brackets here. So we have this head tag that opens the tag, and they also have closing brackets down here, which are the same, except they have a / after the first angle bracket. So the close of our head tag will be this line here, and everything, all this content is within this head tag. So all this here is a single head tag. And all of these tags can be nested. So if we want to find our article headline and article summaries, then we can look down here in our body tag. So we have an opening body tag here, and within the body, we have our test website H1 here, which is a heading. And then we have a div tag here, which has a class of article. And within this div, we have our H2 tag, and the H2 is a
We already kind of get H2.
Guys, UMGC
Bro.
is waiving their application fee through May 30th. So if you've been thinking about a degree
Brutal.
this
file, we can see that it's nice and indented. So in order to format this to where we can more clearly soup imports for that article. So we can see here that this entire div with the class of article has our H2 heading and then our paragraph for the summary. And then this is just repeated down here. So for our second article, we have another div with the class article and then another H2, but this one is for the article 2 headline and the article 2 link, and then the summary text for article 2. And then lastly, we have a footer down here at the bottom that is just with, and up here at the top, it's displayed using BeatifulSoup. So I'm going to open up a file here called scrape.py. Now all we have in here so far are our imports for BeatifulSoup and request. So we have from BS4 import BeatifulSoup, and then we're also importing requests. So let's say that we wanted to parse out the article headlines and the summaries from our very simple.
Okay, so this is the website we're trying to. Let's first. Is it allowed to scrape the PubChem page? PubChem and other NCBI services will disallow scraping via automated tool. Violates their robots and overloads their servers. So some API endpoints are disallowed, but not all scraping is forbidden. Use their API. Pug REST API. How to what chem databases for my SpectroSim project could I scrape? Assuming it's related to. Where's my. Open this up. Let's go back to my. Oh no, it doesn't have it. Use API. Okay, so then should we ask, hey Mitchie, how's it going? Should I ask, so maybe we should be doing web scraping. Maybe we should be doing, how can I learn, well, hold on. I learn how to access PubChem via API. To learn how to access PubChem's information via API, you want to get familiar with the Pug REST API, or Powerful User Gateway. It's designed to be simple and powerful for perfect for programmatic access to chemical compounds like name, structure properties, and spectra when available. Start here. This document describes the REST style version of Pug, a website interface for accessing PubChem data and services. It details both the syntax of the HTTP requests and the available functions. This is more of a specification document. A less formal tutorial style is now available. A less formal. The purpose of this document is to explain services structure, variety of use case illustrations. PUG stands for Power User Gateway, which encompasses several variants of methods. This is small as heck. Small as hell. The REST style interface is intended to be simple access route to PubChem for the things like scripts, JavaScript, embedded web pages, and third-party applications without the overhead of XML SOAP and envelopes that are required for the other versions. Also provides convenient REST also provides convenient access to information on Pub's records that is not possible with any other service. Some other documents may be useful here. PubRest is mainly designed to give small bits of information on one or more PubChem records. Users may be interested in PUG, which provides more complete, longer summary reports on individual public records. PubRest is actively maintained and updated, so check the new features. How PubRest works. The fundamental unit upon which PubRest is built is the PubChem identifier, which comes in 3 flavors: SID for substances, SID for substances, CID for compounds, and AID for assays. The conceptual framework of this service that uses the identifiers is a 3-part request. 1, input, that is, what identifiers we are talking about. 2, operation, what to do with those identifiers. And 3, output, what information should be returned. The beauty of this design is that each of these 3 parts of the request is mostly independent, allowing a combinatorial expansion of these things you can do in a single request, meaning that, for example, any form of input that specifies some group of CIDs, compound IDs, can be combined with any operation that deals with CIDs, and any information output format that is relevant to chosen operation. So instead of a list of separate, narrowly defined service requests that are supported, you can combine these building blocks in many ways to create customized requests. So you have an input of an ID, name, identifier, operation, and then the output is some output. For example, the service supports input of chemical structure by smiles. It supports output of chemical structure in the image as images in PNG format. You can combine these 2 in visualization requests for a smile string. In this case, whether or not that particular chemical is even in the PubChem database at all, and that is something you can almost type manually into a web browser. Or combine the input name with a linCHL property, retrieval, and you simply have to name the service in the single request. The possibilities are nearly endless. XML parsing without any needed programming, XML parsing, etc. At the same time, some more complex data handling is available for programs who want rigorous schema to XML communications or want to use JSON data to embed functionality in a web page via JavaScript. Okay. Basic API structure. Okay, so let's go to our orb here. Let's say, let's walk step by step on how to use the Pug REST API provided by PubChem to get spectrum and UV vis data like lambda max sigma epsilon max, etc. So I can have users make plot data for make spectrum plots for lots of compounds. Let's try here. Step 1, understand the goal. You want to search for compounds by name, smiles, LNCHL, or CID, retrieval UV vis spectral data, Parse and visualize the data for users. Search for a compound. Use the identifier name smiles to get the SID compound ID. Use the identifier smiles to get the SID compound ID. Endpoint. Example for aspirin. Step 3, check for available spectral data. Use the SID ID to query available assays or spectral data. Unfortunately, it's not always available, and so instead it's stored under substance or arrays or assay records. So let's say, without code, I want to learn how to code it myself. So what do I need to do and know about? And can you teach me? All right, it's hyping me up here. You want to, what an API is, how to get requests, how to parse JSON, get Python requests, JSON, tick navigation, pubchem, pub request structure. You'll learn how pubchem structure and data, navigate nested JSON. You'll learn this, parsing this. Okay, so I don't want you to show me big blocks of code. Coach me with words what or pseudocode, how do you spell that? So I can do it myself and interpret what you are saying. Get the SID component ID for a given compound name, gold. Write a function that takes a compound name like aspirin and sends a request to pubchem to get the SID, returns the SID if found. Okay, so that's our goal here, right? What to know? The base URL is this URL. You'll send an HTTP GET request to this URL. If successful, the response will be in JSON format. The JSON will contain a key like CID inside identifiers list. Step-by-step pseudocode. Define a function, build the URL by inserting the compound name. Okay, so let's see here. Let's go, so we'll say def get compound, right? Given a name, right? Which is a string. And I'm going to say that, okay. And we're going to then build the URL by inserting the compound name into the endpoint. Okay, so let's go get the URL. The URL is this. So URL is equal to this. right, and we'll put this in a string format, F string format. Okay, and we're going to put name here. Okay. Okay. Use a tool like request.get to send the request to that URL. Okay, so request.get URL for the new request object, params, direct dictionary, list of tuples or bytes to send in this query string for the request. Quargs, optional argument that request takes, returns request response object. A URL for the new object request. So we're going to say get URL, and then we're going to return here a this is going to be a request object equals this. Okay. So how can I check if request object what's going on, Skewy? Okay, so request.get. So let's look up this real quick. So I want to know what a request response looks like. Let's look up here and go, what does a request.get response object look like? When you call request.get in Python using the request library, it returns a request object that contains everything about the HTTP response, status, header, contents, etc. This response object has many attributes. Here's what you can inspect. Commonly used attributes include the status code, response.status code. Okay, so if the request dot holy cow. The helicopter is really close. You guys can probably hear that too. Hey, Marte! So if the request object dot status code so you just say equals 200. Right? Try the following, except we'll say value error, status as no, we say raise value error as except value error print so if request or response, what can I? If response dot status code is equal to 400 or 404, right? Raise value error. We'll say error 404 invalid search response, something like that. Okay. Okay, so then the whackathon, Mahan. Hey Kansas, how's it going? Sorry. Oh, raid. We got raided? Oh, my bad. Hey Kansas, sorry. Thanks for raiding me. Appreciate you for joining me here. Yeah, sorry. I had my my notes here over the chat. Sorry. What's going on? Yeah, we're building so I have I'm building SpectroSim right now, which is a spectroscopy simulator, right? Using Matplotlib, you can view these epsilons or these Gaussian curves that using some functions I wrote and various compounds, like chemical compounds. So now we're trying to figure out how we can access the PubChem API to get data from its website. So that's our goal right now. Okay, so then let's see. The next step is to check if the response code was status. Okay, parse the JSON to get the identifiers list CID. Get compound CID or get CID, right? So then we'll say response status dot, is it JSON? Okay. So how can you, so you can say response parsed JSON content if applicable. I want to look for what? What do I put in here? Let's see. Returns the JSON encoded content and response if any. Object hook is a dictionary, any parse float, parse int, parse constants, object pairs hook. Optional raise arguments that JSON loads takes. Raise these request exceptions. Okay, so then we say compound like data is going to be what is received by this as a dictionary. And then let's go ahead and print compound data, access the CID. But we want to access it out of it says the identifiers list. And then the CID. So, because it's JSON, it's nested dictionary. So we're saying the identifier list like this. And then we're accessing the CID. Okay, let's try this. So let's go here and say, or let's return this guy. And then let's say print get CID of quote aspirin. Okay. All right, let's see what happens. Okay, we got something. Okay, let's go check. Let's go check. So let's go to PubChem. Let's see if this worked. Aspirin. Where's your ID? 2244. Yo! Yes! Let's go! That's what I'm talking about. All right, so we got the CCID. Look at that! Yo! Okay, that was not that hard. That was pretty easy. So now let's give, like, let's throw some crazy crap in here, right? Now we should get the error. Invalid search response. Another exception occurred. Type error. So let's catch the type error then. Except so let's say accept a type error as let's print this, get rid of this, get rid of this. Now will we catch that exception? Let's try it. During handling, the above exception occurred. So key error. For aspirin. Okay, so if you get a key error, so let's say this, accept key error right, print error compound name invalid. I go to the bathroom here in a second. Yeah, Mohan, we'll probably have to do it like next week, I think, like next Sunday maybe, or maybe just the week after, and get it all lined up when everybody's ready to go. We have to come up with the idea and what we want to do, but yeah. Okay, so let's see if we can catch this key error. Except key error. Catching classes that do not inherit from base is not allowed. Is it this? Except key. Do I have to do that? There we go. Okay. So I can catch the key error like that. Except for a key error, print compound name invalid. Except for a type error, error 404, search, invalid search response. Okay, cool. Nice. So that is pretty good. So now we'll get the aspirin ID though. We give it, it works. Boom. Woo! Look at us. Look at us. Okay, let's give it. Okay, let's say. Okay. I got the function to return me back the SID of the name of the compound provided. Use the CID to get the compound's full data. Write a function that takes the CID, sends a request to Biochemist pug view endpoint, retrieves detailed metadata. Okay, now we gotta write another function. Haha! Let's go! Alright, so def get data via SID. And then you'll put in the CID, which is a what is, let me see, print type of get CID of quote aspirin, and let me do type that'll say list probably, right? Yeah, so then I have to say index 0. It's an int. Okay, so that's good to know. So now that we know that it's an int, so we'll say this. We'll write it here, docstring. Given the name of a compound, search pub chem via pug rest API for the CID this, given the name of the search Pokemon for the CID of the compound within the database, the online database. We'll say the pug rest API returns a JSON response object of a response object of minimal data, like related to a compound, like a CID, like its CID. Okay. And so, given the name of a compound, so this is going to return a, what is this going to return? So we don't want to return, we want to return index 0 and int here. Returns the CID of the compound name provided as an int. All right, let's go ahead and add git commit say func CID request via name function successful. Okay. So now we're going to write this function here. Get data via CID. So the CID is going to be an int. It's going to return, we don't know yet. We'll figure it out. Okay, so define a function. So we need to do something similar where we get a URL. And the URL we're going to look for is this guy here. Pubchem rest pug view data compound. So we say, given the CID, we're going to put this in string and boom, right? So that's the URL. We're then going to say response is equal to a request dot get the URL. We are then going to say try so send a GET request to that URL. If successful, parse the response JSON. So try to go compound data is equal to response dot JSON except for these same key errors. We'll keep those. Okay, so what are we going to return here though? So the main data will be inside the record section list. Okay, so we're going to access the return record, or no, return compound data record, and then section list. Okay. All right, so let's go print get data via SID of the quote of the SID of the get CID of quote aspirin. All right, let's see what happens here. No. So we got this error. Traceback most recent call. Print data via SID get SID aspirin. Name, quote, SID is not defined. Did you mean, unquote, CID? Oh. Ha ha ha. Yes. There we go. All right, let's try again. Bada bing, bada boom. Yo! Let's go. Okay, what did we get here? What did we get here? A whole bunch of crap. Okay, so let me do this. I'm going to write a quick function here called def write write data given some data, which is a JSON. Okay. We're going to say with open, we'll say compound data, and we're going to say this is going to be in write plus mode. We're going to say new line is equal to here as file. We're going to say file dot JSON dot dumps the data object. We have to do this on the file though. How do I do it into the file? Oh, I'm doing with open, then I'm doing dumping onto the file. Okay, so then what we'll do here is I'm gonna call, we're gonna get all the data. This is gonna return the data. I'm going to, instead of printing here, let's just go write data, and let's see what happens. Okay, there it goes. So there's our compound here, and try it again. Boom, there it is. Nothing happened. Let's just do dot dump. Serialize the object as a JSON format to FP write. I'm just going to take this really quick. We'll throw that right here, see what it says about it. Oh, so you dump data onto the file. Like that. That's how you give it into the file. Okay. Okay, there we go. So this is all the data we got. A whole bunch of data here regarding this aspirin. Holy cow. Hey, Zoab. Zoeb. Hey, sorry if I mispronounced that. I appreciate you for coming in. Just wanted to get smarter and just learn more and just keep learning. And yeah, thanks so much for coming in. For interesting. Okay, so now we got that. So I have this write data function just so we can write data and see it. Okay, so we're getting the data. Nice. All right, I have a JSON object that has a ton of data on it. Woo! Moving on. I like this. We're writing it all ourselves, and it's really cool. It's really nice. It's fun. Find the UV vis spectrum section. Write a function that searches the nested section list. So I'm going to go import regular expression. Okay, so now we're going to have to do this. So do I have my old Python notes on regular expression still? You go here, Python, our regular expression. Uh, checks for a match only at the beginning of the string. Checks for a match anywhere in the string. Um, come on. So I need my old notes on this. It's module, syntax errors. So say, or let's do here. Let's put this down. Okay, so let's get add here, get commit. We'll say add func add add additional request via compound CID for more data. Okay, so now what we're gonna do is we want to try and let me just check something right quick. See where my lady's at. Oh, she'll be here soon. I'll stay live for about another 15, 20 minutes, and then I'll have to take a break for a little bit and possibly come back for a late night after hour stream. But I'm going to go to the bathroom real quick. I'll be right back. All right. Welcome back. Okay, so what if I change this to dumps? Okay, basically the same thing. But a list. So I say, what's the difference? Between JSON dump and dumps. It's all about where data goes. Serialize Python object to a file with the dump. Returns a string. Serialize Python object to a string. Okay. So this is going to be dump to a file. So just delete like a huge chunk. If I delete this file. Oh, I'm not actually doing anything, that's why. Right, data. So you're gonna do write data. So if I delete this, make this dumps, then run. Yeah, returns a thing. Okay, cool. Nice. Okay, so then we need to write a function here saying def get spectra data right? And so this will be given some data file, which will be a JSON. And then we're going to have keys equal to a dictionary, where we have a set, I guess, of regular expressions. So I say, what is it? Is it R? And then you go, so I want can you show me an example of regex R string? Oh, rip. My bad. Sorry, bathroom mess is still up there. My bad. Okay. So you could do give me some of the regex operators. Okay, so dot is any character except a new line. Asterisk to start a new string, end of string. Okay, so any character. So write a function to find UVis section data. Inside of it for keys like this. Okay, so maybe we don't need regular expression.
Got a billion-dollar web app idea? Now you can turn it into reality with Hostinger Horizons.
No. Leave a like if you guys are here. I appreciate you being here. We'll potentially play some League tonight if we are feeling it. Depending on my girlfriend's coming over, so depending on how late she stays up, if she goes to bed early, then I'll jump on and play some League and watch some coding videos and read some articles and stuff and just do like a hangout stream tonight. Okay, so get Spectra data. So we want to get Spectra data here. So keys is equal to this. We'll say this compound has data in it. What does it look like again? Get data. Write data. So then if I control F here and I look up, let's look up spectrum. Okay, so this gave us string spectrum, string spectrum, spectrum. Reference number, spectrum type. UV max. Max absorption. Max absorption. So maybe we do need a regular expression here. We want to get, if the key has max absorption in it, we want to take that. Okay, so let's say keys are set, we'll say this is going to be any character, right? So a word char, we'll say word char, right? A word char. What does word star plus mean? One or more of the preceding. So any character one or more times. This list goes on. Information. The information key of the
Step into Wix Studio, the platform for agencies and
TOC
enterprises.
heading.
Kick off projects in a workspace that's designed for your workflow. Work seamlessly.
And this is the key of it. In your description. So this stays open until here. So this is the section we want, is TOC heading to here. No. Where was our values? 60. Let's say max absorption here, right? So this ends back to so this gives us this gives us UV max. All right, you guys. Unfortunately, I'm gonna have to pause the stream here. I really appreciate you guys being here and joining me so far. I'll be back probably later this evening on a part 2, but I'm going to spend some time with my lady friend today. She's coming to visit me, and yeah, so I appreciate you guys being here. Please join my Discord link down below and get access to our upcoming Whackathon, which is going to be a community-driven hackathon that we'll do probably next Sunday or maybe the week after that, where we'll all build a project together. Thank you guys so much for joining me here. I appreciate you being here for the time being, and I'll see you later tonight.